4 of Cloud Tech 10 for the 3rd of April 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. Azure Functions added a new preview feature to support the editing and hosting of OpenAPI 2.0 or Swagger metadata. Swagger metadata allows a whole network of Swagger compliant software to easily integrate with your APIs. It also makes it easier to consume your API in services such as Power Apps, Flow and Logic apps. Creating Azure Functions is quick and easy, and so is working with Swagger. Let's create a simple Azure function. I'll add a new function app in the portal. After a minute or so, it's deployed. Let's add a new function. I'll choose an HTTP trigger and name it Hello Trigger. Some sample code is provided to get you started. This code simply looks for a key value pair with a key named name, and the value of that key is simply returned with hello in front of it. As we only have a post method in this code, I'll click on the integrate tab here and clear these checkboxes so we only have the post method left. Next, click API definition down here, set the source to internal and wait a few seconds whilst the API definition is generated and loaded. The also generated document is an outline of a full Swagger document which needs some values populated. So for the purpose of this demo, I'll just paste that extra info in. Now I have a Swagger definition that's being hosted for me with my function. I can copy this URL for the API definition and paste it into a new browser window to see the Swagger file. I can provide this URL to any application or service that knows how to work with Swagger files. I can use the functions UI to test the API definition. I copy my API definition key from here, then authenticate and paste the key in. Now if I scroll down to the bottom where the request details are, I can add a value to the name key like this. Scroll down here and click send request, and here I see the response back from my Azure function. The Web Application Firewall feature of Azure Application Gateway is now generally available. A Web Application Firewall, or WAF, analyzes network traffic looking for malicious activity. The Azure Application Gateway WAF can help protect against attacks such as SQL injection, cross-site scripting, command injection, HTTP request smuggling, HTTP response splitting, remote file inclusion, HTTP protocol violations and anomalies, and denial of service. The Open Web Application Security Project, OWASP, publishes a list of the top 10 most critical vulnerabilities. Azure Application Gateway WAF comes pre-configured with the OWASP Mod Security core rule set, which provides baseline security against many of these vulnerabilities. To add a WAF to your network, add a new application gateway. After you've provided a name, you can choose whether the gateway will run as a standard gateway or with WAF enabled. After selecting a SKU size, instance count, resource group, and location, you provide the details of the network that the WAF will be deployed to, including IP addresses for the front end and which protocols and ports to listen on. You can also select whether you want the WAF to run in detection mode, which causes the WAF to log malicious traffic, or prevention, which will block malicious traffic. Once the WAF has been deployed, you can turn on diagnostic logs. Logs can be configured to be sent to an Azure storage account or sent to event hubs or log analytics. This makes it simple to perform further analysis on log information and send to alerting or management services as required. You can choose which rule set the WAF will use or drill down to enable or disable specific rules. The CRS 3.0 rule set is the recommended option. Azure Relay Hybrid Connections is now generally available. Relay is used to securely expose internal applications to the cloud without having to make major changes to network or firewall configurations. Service Bus Relay was one of the first core Azure services and originally was designed to work with WCF applications. Hybrid Connections is built on HTTPS and WebSockets and opens up the Relay platform to work cross-platform on Windows or Linux with .NET Core or Node.js. Here's a sample Relay hybrid connection built with Node.js. In the Azure portal, we create a new relay, giving it a name and choosing a resource group and Azure region. We need to get the access key so that we can connect to the relay. Click on Shared Access Policies here and then choose the Root Managed Shared Access Key option. Copy the primary key value as you'll need this later. Now go to Hybrid Connections and add a new connection. Give the connection a name and leave the remaining values at their defaults. Now we will write two short Node.js applications. One will send a message via the hybrid connection. The other will act as a server and listen for messages on the hybrid connection. For this example, the client application will run on a virtual machine in Azure. The server application is running on my development workstation, which is a physical device behind a firewall on my local network. The listener application could quite as easily be a server sitting in an enterprise data center. The point is, I'm not making any changes to my network configuration to permit these two applications to talk to each other. Let's create the listener application. I need to install the Hyco WS package. Then let's go to Visual Studio Code and write the listener application. I set a constant to reference the Hyco WS package. Now I need to provide the parameters necessary to connect to the relay hybrid connection. So that's the name of the namespace, the name of the relay, the name of the shared access policy, and the primary key value. I'll paste the rest of this code in. The code creates a relay server and starts listening for connections. Next, let's create an application to connect to the relay service and send messages. As before, I need to install the Hyco WS package. Next, back to Visual Studio Code. I'll set a constant to reference the HiCodeWS package and a constant for the readline component that we'll use to read input from the keyboard. I provide the same values as I did for the listener application to connect to the relay hybrid connection, and just paste this code in, which will receive keyboard input and send that input to the relay service. Right, let's start our listener, which will be running on my workstation, and let's run our sender application on the Azure virtual machine. So if I type "Hello, this is a test message" on the sender and switch to my server application, I can see that it's received the message and printed it to the display. Seems simple? Yes, it is a simple demo, but remember, the server application can be inside a corporate firewall and will likely be a more complex application, perhaps connected to a database or a REST API. The sender application can be located anywhere, but can still establish a secure connection to send and receive information to or from our on-premises services. If you want to get started quickly, there's a GitHub repository available with samples for .NET and Node.js. Azure Monitor, Azure Advisor, and Azure Resource Health have all reached general availability. The Azure Monitor is a platform monitoring service for Azure. With it, you can create queries to look for information within the log files of your Azure resources. You can use it to look at a wide range of metrics, and you configure alerts for events, which can then notify via text message, email, or webhook. Azure Resource Health watches your resources and will inform you if they're running as expected, or of any past issues that may have had an effect. And the Azure Advisor can provide recommendations and best practice advice to help you optimize your Azure resources. It looks at availability, security, performance, and costs, provides recommendations, and can even help you to apply changes to remediate potential issues. Two new features have recently been added to Azure DevTest Labs. First, virtual machines in DevTest Labs now make use of managed disks. Managed disks simplifies the process of creating and maintaining virtual hard drives for virtual machines, removing the additional overhead of having to manage Azure storage accounts. Second, lab usage data can now be exported programmatically, making it easier to manipulate and visualize using tools like SQL Server, Data Lake, or Power BI. Syscoin have recently added 3 blockchain products in the Azure marketplace. They are the Syscoin API server, the Syscoin price peg server, and the Syscoin full node. Developers can create blockchain-enabled applications using Syscoin's suite of decentralized business services, including digital certificates, secure messaging, marketplace offers, payments, and escrow transactions. The Azure Marketplace offerings make it simple to get up and running quickly. You only provide the same information that you would for any normal virtual machine deployment within Azure, and within a matter of minutes, a Syscoin full node is ready to use. Azure Data Factory data movement is now available in the UK region. Whilst Azure Data Factory itself is currently only available in regions, the service that powers data movement is deployed across multiple global locations. When copying data to an Azure data store, such as blob storage or Azure SQL database, Azure Data Factory will use, if available, a data movement service located in the same geography as the target. For example, if you are a UK-based customer who needs to comply with data residency controls, this means you can be sure that data being copied by Azure Data Factory to a data store in a UK data center will remain in the UK. The Azure Data Factory documentation contains a full list of locations where this service is available. The latest payment card industry data security standard attestation of compliance document has recently been published. This is an important standard which all online retailers of any size who handle payment cards from major card brands such as Visa, MasterCard, or American Express must comply with. The latest update now includes the UK Azure regions and additional services including DocumentDB, Data Catalog, Machine Learning, Functions, and Virtual Machine scale sets. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share, and subscribe, or follow me on Twitter. I'll see you next week. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe, and follow me on Twitter for more.